Are you ready? Yes. All right, I'm going to welcome you to our presentation. We are group 5. On the very left there is Camille. Then right here is Stat, and I'm Jonas. And we will talk a little bit about functional reactive programming. And first, I will talk a little bit about functional programming basics, then Dat will take you through the reactive aspects of functional reactive programming, and then Camille will talk a little bit about the libraries that can be used for that and what we do in our project. So functional programming basically is, you take computation as the evaluation of mathematical expressions or functions. And this way, every time you put the same input into a function, you will get the same result. So you don't have any side effects that affect the outcome of the evaluation. And the goal of functional programming is to make code easy to understand and allow easy prediction of the outcome, because you can validate it with mathematical systems. And I will talk about 3 basic functions, being map, reduce, and filter. And I will start with map, and here you can see some data. This can be an array, list, or even a data stream. It's just any data structure. You can use this for self-defined data structures if you implement your own map methods. And what map does, it applies a function to every single element of the data structure. So here, if you take a function like this, which basically multiplies the element by 2, and then use it on this data structure, you will get the result looking like this, where just every single element is multiplied by 2. And that's all map does. It just applies a function to every single element. Then you have a function called filter usually, and this takes in an expression that evaluates to a Boolean, so it can either be returned true or false. And if the function returns true, it will keep the element in the data structure, and if it is false, it will throw it out. So if you use this function, which returns true for every number greater or equal than 4, you will get the result down here. And if you would use this example on an array, the array will be shorter in the end, because all the numbers that return false will be thrown out. Now there are a little bit more complicated functions like reduce. There's 2 basic functions. There's reduce and reduce write. And what they aim to do is they want to reduce the data structure to a single value, or to a single data object. And what you need for that is you need a function that you want to use, which works on the data structure. Usually a start value, but it's not every time it's necessary. Sometimes it is. And then the data you want to work on. So if we take this data that we got from our last function, the filter, and we want to reduce it. And reduce in JavaScript is basically a fold left, and in other functional programming languages like OCaml and Haskell, it's called fold left, I think. And what it does, it takes the first element and the second element, and it uses the function on them and takes the result and uses it again as the starting value. So if we say we use the function add. So we add the first and the second value. We take a start value of 0 and we use it on this data list. First we would add 0 to 4 and then take the result and pass it to the function again. And then the result we get in the end would be the result of the reduce. So we use our multiply add on 0 plus 4, because 0 is our start value, 4 is the first value. Then we take this and use it as input for the next function call, where we add 6 to 4, and then we do it again. And this way, in the end, we get the result of 24. And reduce write works very similar, except that it starts on the other end of the list. But well, it still starts on the first element, but it starts evaluating at the very end, because you take look at the first element, and then you use the function on the remaining list and take the result of that and add it to 4. And this way you travel to the very end of the list, get do the last calculation of the last application of the function, and then take the result and pass it back to the calling function. and you get the same result in this case with that function. There are differences, which I will show you now. If you use reduce, it is tail recursive. Does everybody know what tail recursive means, or should I explain it?
Yes, please.
Okay, so tail recursive basically means that when you have a recursive function call, you don't add another function call to the call stack. You just keep it, you only have one function call. Yes?
Is it in German Entrecursion?
Yes.
Okay, then I know.
Yes. That's what it is. So if you're a tail recursive, you don't add function calls to the call stack. You always evaluate the function and pass the result to the same function again, but you don't have the call stack building up. And in the case of reduce write, we have this problem that we keep adding the function calls to the call stack because we have to get to the very last evaluation and then take the result and pass it back up. So we have this problem of building a call stack, and depending on the data structure, this can be problematic. And in the case of the addition here, we have it is not left or right associative. You can like put the brackets as ever you want, and we'll get the same result. But if you have a left associative function, you should use reduce, and if you have right associative function, you should use reduce right, because left associative means it will evaluate the left side of the calculation first and then do the right side. So you have to keep that in mind when programming. So now you think this basically does the same thing, so why should I bother thinking about it? If we take the example of the addition, we get the same result. But if you look at something like a function that concatenates list elements, and we take the starting value 0 again, and we would use reduce on this and start with the value 0 and then just append the next value, we would get the result of a list containing 0, 4, 6, 6, 8. But if you use reduce write, we will pass the starting value to the very end and then append it first and then do it again. So we get the two results, 0, 4, 6, 6, 8 and 4, 6, 6, 8, 0. So depending on your function, you will get a different result, or maybe not, for reduce and reduce write. And I have an example in JavaScript here for you. This is reduce in arrays. So the arrays prototype has a reduce function built in, and this takes a callback function that has 4 parameters, which are the previous value, current index, and the array. And this is the information you work with in your function. And if you would define a function, you could, example, use previous value and add it to the current value. This is basically what we did in our example before. And then if you want to call it in JavaScript, you would have the array, and then reduce. And this is the callback function. This could be this one. And then there is the start value, which is optional. So you can use a start value, but you don't have to. Okay, that's it for my part, and now that will take you to the reactive part.
Thank you. Okay, so let's talk about functional reactive programming. Yeah, first, first the definition. So functional reactive programming is just you use the block of functional programming like map, reduce, and filter to handling the data flows. So in our case, it will be event stream.
Can you guys hear me back?
No, we can't at all.
Okay, so sorry. So yeah, also functional reactive programming is you use building blocks of functional programming like map, reduce, and filter to handling the data flows. And in our case, it will be event stream. So FRP is a concept, and you will see it in other language like Java, C++, or Haskell. So what is a event stream? That is a scale form of event like keyboard, mouse click, or even an input data. A property is just a variable whose value can be changed during the runtime and depend on the event. So the benefit of functional reactive programming does first, so no explicit time handling. Thus, so you don't have to specify which event is must to have to happen first and which event have to happen next. Yeah. Second, no explicit pass on chain value. Thus, you have if you have a property that depend on another, and you change the value of a property, and yeah, it will automatically provoke the chain on the former. And the last is every property has only one definition, so I will talk about later. So the first example, so we consider a counter that can be counted up to 1 by pressing a up button and down when we pressing the down button. So I brought you two solutions. On the left hand is the solution with the jQuery, and on the right hand is the solution using Bacon.js. So on the left hand is
Bacon.js is what?
Yeah. So
what is Bacon.js?
Also, it is a framework that we will talk about later using functional programming. Yeah.
Okay.
It's a library basically for functional.
Thank you.
Yeah. So on the left side is just every time we click on the up button, we trigger an event and we increase the counter variable to 1 and we set the text. Yeah, the same thing for the down button. On the right hand side, we define two event stream, up and down, and then we basically said that I want to map the up event stream to 1 and the down event stream to -1, and then we combine two event streams together using the merge. So what is the difference from these two solutions? Okay, let's assume that you know nothing about the code that I introduced you before, and yeah, someone asks you just a question that what is the value of counter after n time you press the up button and m time you press the down button. So yeah, the first thing you have to do is how do I go back?
Back button now.
Okay. So the first thing you have to do is you have to look up the counter variable where it show up in both cases. Yeah. On the left, on the right hand, you only have is here on the counter is. So you almost have the information what you need to answer the question. But on the left-hand side, it's more complicated because the counter variables show up in 3 different places, and yeah, you have to go through it and find out what this function that does. And yeah, it will be more complicated if you have one function here and one function in somewhere else in your project. Yeah, it's hard to check down your code. Okay, so the next example is the user is focused when he watching this window, else not. It's similar to the last example. Nothing to discuss here. And then, so the next example, the user is active when he moves the mouse points or press some key within the last 30 seconds. So you will see that with jQuery the solution is a little bit complicated. We have a active variable, and then every time we move the mouse or we press some key, then we call the function. We set active we assign active is true, and then when nothing happens in 30 seconds, we call the set timeout function and we reset the whole thing again. Yeah, a little bit complicated, but with Bacon.js is simply is very simple. You have here an event stream activity, and you map it to true. And after 30 seconds, when nothing happened, you map it to false. Yeah. And the initiation value from activity is true using the toProperty function. Okay, then we let's combine the two event streams together. Let's say the user are viewing the page when the window is focused, and he has moved his mouse or pressed some key in the past 30 seconds. So I don't write out the solution with jQuery here because it's a little bit ugly. So, but with Bacon.js is question. Also, but with Bacon.js is it's very simple. You just combine the two event streams together using combine or just focus.and active. So that was my part. Then can we continue?
Yeah, thanks, Doug. So now you've learned about the technical aspect of functional reactive programming. I will take you through two widely used libraries. So probably the two most used libraries in functional reactive programming are on one side RxJS, which is part of the reactive extensions, and also Bacon.js. So as for RxJS, it's actively developed by Microsoft. I think they created it with .NET and Java in mind, but they basically ported the whole project, so the reactive extensions, to a whole lot of platforms. So there's for Java, there's for Swift, for Python, so you can basically use the skills you've acquired for RxJS on all platforms, since it is syntactically almost identical across platforms. And then the other one is Bacon.js, which was heavily inspired by RxJS. But there are a few notable differences which we'll get into later. But from the basic concepts, they are pretty similar in usage. So, but before we go into the differences, let's once again, let's talk about observables. So that told you before about event streams and properties, and basically this can all be combined under the term observable. So what is an observable? It's basically, which you can see on the diagram, it's a stream of events that is ordered in time. So you have events. You can have, in this case, we have 3 events. Then we have an error event and an end event. And the thing is, to this event stream, the values are emitted asynchronously. So and then there are 2 possibilities to get out of an event stream. So it's either by an error event or just by an end event if you're finished. Or it can just run indefinitely. And why is it called observable? Well, it can be observed, hence the name. And what we call to observe in the functional reactive programming is basically we subscribe to the observables. So maybe to show you an example written in RxJS. I hope you can all read it. Can you read it?
I don't think anyone would read it, because there's too much.
Too much on it. But okay, let's see what.
So basically, there's a lot of code, but actually it's pretty simple, so I will walk you through it. So what we want to do is we want to check whether a user clicks, and if he clicks, we want to determine whether it was a single click or a multiple click. So at the beginning, we define a click stream variable, and we do that by calling our x.observable, so we get an observable, and we want this from all the click events. So what happens is, in the event stream, click stream, we just accumulate all the click events that happen. And then an important part of functional reactive programming is that you can take a stream and just combine or just use it to create different streams. So at the moment we just have all clicks in there, but we don't know if it's single clicks or multiple clicks. So what we do is we create two different streams. So the first one is single click stream. The first function we call on it, buffer, just accumulates all the clicks that happen in the same 250 millisecond window. So basically after 250 milliseconds, the counter is reset, so we check once again. And then we get the amount of clicks that happened in this buffer, and then we apply the filter method, which you've seen earlier. So we only filter out all the clicks that or the events that were just one click. So basically in a single click stream we have all the events of single clicks. And for the multiple click stream it's the same, just that the filter function is a bit different. So we get all the events where we had two streams or more. And then what happens at the bottom? We can subscribe to each stream. So basically if there is a single stream event happening in the single click stream, we just log single click, and the same for the multiple click streams. Is this understandable? Maybe lots of clicks, but I think it should be pretty easy. If not, please tell me. Yeah. So now that we've introduced this notion of observables, we can actually compare RxJS and Bacon.js. So in RxJS, everything is an observable, so we differentiate between cold observables and hot observables, but they are both part of the same object class observable. So what's the difference between the cold observable and hot observable? The thing is, cold observables are lazy evaluated, so that means you only actually get starting events in your stream when you subscribe to it. So as long as there's no one watching, there's nothing happening in the stream. While a hot observable actually is always emitting events and data, and not also even if there's no subscribers. A benefit of RxJS is that in comparison it has relatively low memory usage. And also, which I mentioned before, it's designed to be consistent across many different platforms. So I think I read an article about Netflix where they also use functional reactive programming very heavily. And they said they can just move around people from front end to back end. And since they are using the reactive extensions or the reactive aspect all over their code, you can just move the developers around and they have almost no introduction time. So they can just start working immediately.
Why is that? Why they
because RxJS is just part of these reactive extensions project from Microsoft. So you can do basically the same thing as in the example before with Java, with the RxJava package, or in Swift, or in Python, or with anything. So, but syntactically it's almost the same. So there's no introduction time if you switch from front end to back end, because from the logic it's the same, also syntactically. Yeah. And then as for Bacon.js, you distinguish between event streams and properties, which that already talked about. So an event stream is basically like the observable you've seen before, and the property is also an event stream, but only with a state, so it has an encapsulated value which can change over time. So maybe a little example, you could think about an event stream as all the click events, because they don't actually have a content, they don't have a value, but they are just events. And a property would be, for instance, your mouse position. No matter where your mouse is, it has always a position whether you move it or not. Yeah. One disadvantage with Bacon.js is that it's not as memory efficient, than RxJS, but then again, it's custom tailored to JavaScript, so it's only available to JavaScript, and it also makes use of all the language features that JavaScript offers. Yeah. So in our project, functional reactive programming could be very useful to process an incoming stream of tweets. So when you are connected to the streaming API, they just come in as they happen. So you can think about that as an event stream, and then we can just make usage of the tweets as they come in. We'll talk about that later in our project part. It also reduces the need for callbacks, and the general readability and structure of our code is improved, since as long as you actually understand the functional reactive programming aspect, it makes it easier to read and to understand as soon as you've understood the concept. Yeah. So that's the part about functional reactive programming. Question?
Okay, so can you go back to slide 19?
19?
Okay, so and once again, imperative versus FRP means in imperative we both. Okay, state the difference. State the main difference between imperative and FRP again. What's the main key difference between ideas of these two pieces of code?
So is the main difference here is when you track down the code, something when somebody asks you, so at a specific time, which value has counter. So what you have to do is you search in your project for the whole place where counter show up, and you go there and you have to see which function, what's this function doing, and how it's changed the counter variable on the left side. But on the right side, you have only the counter only in one single code here. Thus you merge it to from up you merge it to 1, and from down you map it to -1. So it's easier to check down your code.
I have questions. First is what does scan does?
The scan does is so the initial variable, the initial value from counter is 0, and then you and then after the event stream happen, then you plus the mapped value together and assign it to counter.
Fascinate for its use?
What is scan? What does it do? I understand what it does in the example. I want to understand what is this function. I understand what map does, I understand what reduce does, I understand what filter does. What is scan?
Scan is, if I remember correctly, similar to reduce. Just when you use reduce, you or fold left, you just fold it back to a single value, while with a scan, you just apply the previous result to the next element in your data structure, but you keep the previous elements. So you would have an array just of ones.
Accumulator? Accumulator?
I don't know.
So as an example, if you have an array of ones, and then you apply, you do a scan with the function plus, what you get is 1, 2, 3, 4, 5. And if you would just do a fold left on it, you would get the sum of the stuff. But in this case, I think you just, I don't know really.
Okay. So that if you can email us like an explanation of what scan does, that would
Can
yes.
Google group it in a better?
Yes.
What's that?
Google group it.
Yeah. Google group it.
I'm going
And Jonas, right? You
Yes.
presented first. You said that functional is a different way to present our code and actually makes it a little bit more clear, right?
Well, that was the main goal of functional programming. I mean, JavaScript is not a functional programming language. It takes aspects of functional programming and incorporates them because they're very useful.
What do you mean it's not a functional language?
Pure functional programming language like OCaml has.
Right.
Okay, that's a different story.
Yeah, but it's not. It's not a pure functional programming language.
So the statement that you had about functional programming languages,
This is just the goal.
does it apply here or no? Not really. I mean, when you come, well, I'm new to functional programming,
Yes.
and I want to use the approach using Bacon.js. Would you recommend that I write the code this way or the interactive way? What would you say it would be a more
More easy to learn or
well, you said that it's an easier, that it makes code clearer. So what would you say is makes code clearer here?
I think the Bacon.js approach makes it easier clearer because map always say you see the function and you see map and okay, this is going to apply the function to every single object. Mm-hmm. And if you see something like reduce or filter, you know exactly what it does, and you see the function and it just you know what's happening.
To your answer. So I would say that for me, functional is in some sorts and in some cases easier because there is no, a spread all over your piece of code, manipulation of state. It's always some data, and operations on this data are stacked next to each other. They're chained next to each other, so you don't need to keep in mind what was my state in the beginning, what it was after 5 steps, what it is now.
You only have the function, and the output is every time going to be the same if you have the same input. So once you understand your function and your input, you know what the output is going to be without knowing what the rest of the program does.
But I have another question.
Yes.
So okay, that's functional programming, that's all great and good and fancy, but I want each of you to state just in one phrase what's the goddamn difference between functional programming and functional reactive programming. Because so far it's been very blurry.
Yeah.
Go ahead, start.
Yeah, so functional reactive programming, so the reactive part just means that you have to deal with these streams all the time. You have event streams, observables, however you want to call them. And
so
then
if we throw away streams, we cannot have functional reactive programming.
I think so, yes. And then on top of these streams, we apply the aspects of functional programming, like map, reduce, filter. So, yeah.
Is it possible to use Bacon.js without functional programming, like actually apply imperative programming on those screens?
I don't think so. I think it's explicitly made for use with functional methods.
So what's on the code to the right is coming from Bacon?
Sorry, your question?
What on the right-hand side is coming from Bacon? So for instance, we have on the left side for jQuery, we obviously have the selectors, we have the on function, I guess the DOM modifiers. What's coming from Bacon?
Basically, on the very top, you define your event streams up and down. So this method as event stream comes from Bacon. Mm-hmm. So this returns you a Bacon.js event stream. And then on top of these event streams, also by Bacon, you can use the map function and merge and scan. So basically, yeah, that's it.
All right. Questions about this difference between functional programming and imperative? How many of you are functional programmers? Have done functional programming before?
Done it?
Well, done it to any degree.
How many of you have done functional programming for life? I mean, just put bread on your table.
Do you know something about the difference of those approaches?
You mean like runtime wise?
Yeah. Does it matter?
Actually don't know.
I'm convinced that imperative will always be faster and more performance because it is simply closer to the underlying model of calculations that is performed by our hardware. generating functions. Well, I guess that can be, you can do that with some.
Is this a general statement you're making, or just for JavaScript?
I'm talking about all functional programming in general.
I would disagree with that. I think that you can do with that functional programming a few things that you can't do with traditional way of approaching problems.
Well, the question is what happens if you compare it versus functional programming?
The performance?
Yes.
I think
in the end, all your functional code gets translated into imperative code when it is run in the CPU. You do agree with that? Yeah.
It's just optimizations for the end result.
So this example, by the way, can you run it through JSPerf and let us know which one performed better?
Yes.
All right. So we have two things waiting from this group. We need to understand what scan does and which one we're getting a better performance. Other questions about this? So, did you recommend using FRP for event handling, or is it just a waste of time?
I think
Or is there a specific context?
each of us hasn't had enough time to really dive deep into it. So I actually don't know yet. I mean, also to answer the question on the microphone.
So should we move on? Or should
Yeah, just keep on going.
Yeah. So also to respond to the question before, whether you have an actual, what the benefits are of using functional reactive programming. I mean, the main incentive would not be maybe performance-wise. The main incentive would be to improve your code, to make it more readable, to improve the structure, so you can more easily understand what's going on, actually. So, I mean, with the earlier group, we had the example of the callback hell. So, another way to get out of callback hell would also be the functional reactive programming aspect. So, I think that there lay lots of benefits, but I don't know if either of us can comment on the statement whether we are now fans of functional reactive programming or not, because I think this takes more than just 2 or 3 weeks to dive deeply into that. I think it's more like a really big shift. Yeah.
All right, so I know at this point.
Yeah.
All right. Yeah, anything else on functional reactive programming? Good, so now we move on to the project.
So, yeah, project report. You probably mostly heard some of this stuff with the earlier group, so maybe going through it a bit quicker. So, what is our preferred outcome? We want to, for each character, based on the time, create a sentiment score for Game of Thrones. So maybe in episode 1 of one season, Jon Snow is very popular, and then in episode 5 he does something which makes him very unpopular. And we want to be able to basically, out of the Twitter reactions, generate this trend. We want to know at which point of time what the sentiment score for the characters is. So we have a data pipeline, so we get our main data from Twitter via the streaming API and the REST API, also filtered by episodes, and then what we do, we run those tweets into the sentiments analysis package. We create a score, or we calculate a score. We put all this into our database, which is a MongoDB hosted with MLab. And then after that, out of that data that we have in the MongoDB, we can create a visualization, so you can actually do something with the data or just watch it in a good way. So the current state of the project, we are able to read the Twitter API, both streaming and REST API. Yeah, we have set up our own cloud database. But with MLab, we are also able to connect to the database from Project A and pull out the information that is gathered there, as far as the REST API from Project A allows it. And then we are also able to put these tweets into the sentiment package and run them through the analysis. Yeah, the resources we are using is the standard Twitter package for Node, the sentiment package, which is also, I think, the same. I mean, it's basically pretty much the same that Group 4 is using. So,
What's it called?
Sentiment, yeah.
Just sentiment. And provided by Twitter?
Twitter or sentiment? No, the sentiment analysis package is actually separate from Twitter. It just takes a string of text and it has a list of words that are associated with the value, and it just calculates a score out of the words in the text. So you can use it on any text.
So these are separate parts in our code. We pull the tweets and we put them into the sentiment analysis.
Do you know which approach they use to write the sentiment analysis? Just counting how many words, how many times a positive word was mentioned?
I'm not sure how it works, actually.
Pardon?
I'm not sure how it works.
Okay.
We just take the number.
There's a way, by the way, there's a way to retrain the sentiment.
Yes, we have a training file where we can add additional words that are not actually in the in the word list. And so, for example, like poopy head isn't in the word list. So if somebody tweets Jon Snow is a poopy head, it doesn't get recognized. It gets a score of 0, but it actually is like negative. So we have in our trading base the word poopy head with a score of -2.
Did you do it? Did you?
Yeah.
Did you retrain that?
Yes, it works.
Second small question is the binary outcome for characters like they have, or is it more fine grade, like something like not just like or dislike, but you know, like Facebook implemented now the heart and the love.
No.
So that's different.
It's just an integer value right now. And then we store it for every tweet. And we don't actually store the text of the tweet, we just store the sentiment score and the tweet ID and the date. Then we try to make something out of that.
Wait, can you treat emojis?
Yeah, of course.
No, I mean, can you read those emojis?
From Facebook, that's the whole point why they implemented it.
But you read them as well. You read them as well.
Different sentiments. Every emoji is different sentiment.
They're translated to what? Like if you want to read emojis, you read them as code?
We don't read emojis right now. We only read text.
No, but we can. It's Facebook. I mean, they
Facebook, yeah.
No, in fact, on Facebook, because they don't have likes, they have like hearts and shit now. I don't know.
Right. Okay.
There's one question.
For the implementation, I think there's 3 popular packages for an API. And all of them use the naive bias code. Yeah, so it's just approach that works best. Like, you could use different algorithms, but yeah, this is just naive approach. Works quite well. So you basically give a score for each of the words and then you can combine it to one big result. There's one package which also, well, for example, if you have a not in this tweet, then if you just take the single words, it might be all negative, but if you put a not in front, then it's all inverted. So it's one package called getText something, which works a bit better than the sentiment. Yeah, it can work works better than the sentiment package because it handles emojis and
and not. Yeah, that's what I'm thinking about. Really, what to do with not? If you put like something, a combination like amazingly stupid. What is it? Is it like a 0 score? Because it's not. Because the first positive word amplifies the second negative word.
Right.
That's like stuff we can think about.
Currently, it's not being implemented.
No, I think our first goal is like to get the thing running, and then we can improve it. Because we're all like me and Kevin at least. We're first time JavaScript users.
Okay.
And yeah.
It's really simple to exchange the packages, or to train. You just pass one string to a function and get a result of the integer value. It really doesn't matter how to implement it.
Yeah, you can actually just make it like at runtime and have like different analysis. Like you can run one with the sentiment package and see what the different actually are.
Well, what are the alternatives? What is the other package?
What was the other package?
Text sentiment.
Text sentiment. So you could like
sentimental, but it's the same as sentiment.
you could use like different packages and see if there actually is a big difference or if it's a small difference. That would be interesting.
It would be an interesting, yes.
Yeah.
A consensus algorithm. You can write a consensus algorithm.
Yeah, that's true. You get all 3 packages running at the same time, and then each of them take a vote.
Yeah, but for us, that's all like stuff that we would want to do. But right now we have like bigger problems, like basically to get the thing running.
Yeah.
You're saying that you're overloaded.
We do what?
That you're overloaded? That you have too much on your hands right now?
No, we have our goals are pretty clear what we want to do now, but all these things are like nice to have, but we have stuff that we have to get done first before we can think about that.
Okay, so where do we stand right now?
That was the state of the project right now. Yeah.
Okay.
And we have a visualization based on dummy data right now because we don't have the actual data available right now.
You do not have the actual data because you're still waiting for it, or just the...
No, because we have to like read the tweets and store it in our database. That's basically the same problem that the other group has, that you have like a strict limit on where you can go back.
And also it's difficult to get the older tweets because of the search API.
I see.
Yeah.
By the way, so how does that work? You get a token from Twitter and you use that token to mine
Yes.
tweets, or
Yes.
yeah? So you could generate many tokens and have it run from various IPs.
Yes, but you have to put a developer account with a different phone number each.
Okay, so
Now,
it's not easy.
can you register several apps and just use it for authentication?
Yeah, you can use the same OAuth as the same Twitter tweet account that you use.
Okay.
The limit is per account.
Oh, that's good.
I think the limit is per account or per...
The limit is per, I don't hear it, sorry.
Per account.
I had to try to...
Yeah, because that would be stupid.
If you do the searches, I think it's per account, because it's
Yeah.
a user action, not an app action.
That would be stupid if you just generate like more keys for your account and then...
Also, we're currently pursuing a third approach, which uses a mobile site. There's a mobile site which is static, and I'm not entirely sure if they have to do like request limiting there, but you can pass the mobile site and do searches there even further in the parsing. So we might at least that a bit.
And then so far you haven't.
We just have tried a bit experimental stuff, but we don't have a whole parser for the tweets yet.
Okay.
Yeah.
Do we have it then? Do you guys
We have a visualization.
Yeah, which...
But not...
Yeah, with dummy data, but... Yeah. So to continue, some problems that we've encountered is, first of all, we had to agree on how we would want to persist the data we gather. So in the beginning, it was an idea that we would just store a local JSON, but after some time, it became pretty clear that we want to have an actual database running. So we solved that by using the hosted MongoDB, and also how we want to filter the tweets and how to deal with spelling errors, because you might imagine there are lots of people tweeting about Jon Snow and writing John with an H. And so we have to deal with that. And also filter by hashtag maybe. So we have to...
Are you dealing with this, or are you just...
No, but that's on our next steps. But what I'm going to do next for the streaming API is implement the way that you can search for like a main character name and put alternatives as well in the search object, and we'll search for all of them, but only store it under the main correct name in the database, so we get all the alternatives.
Yeah, the problem is also with the spelling errors and everything that there aren't that many tweets being sent out at the moment, like compared to when the episodes actually air. So yeah, it's a bit different.
Jon Snow sucks every
with different variations of John.
What are the frequencies? Like how many are you getting?
I don't know. I only tested it for a couple of seconds. I don't think there's a point in running it.
I think if you do a...
Same where it is right now.
If you use the REST?
If you use the REST API, for instance, I tested it with Tyrion Lannister, and you get like maybe 7 or 8 tweets at the moment, but I don't know if that's also some arbitrary limiting by the search API, or if there's actually not that many tweets happening at the moment. I mean, it's surely more than 7 tweets, but maybe put into perspective, I don't know how many there are. Okay. Yeah, might. Yeah, because we filtered for popular tweets. Because you can, via the Twitter search API, you can basically apply 3 filters. So the first one is popular, the second is general or standard. The third one is just give me everything. So popular tweets are the ones which are liked lots of times and retweeted. So there's actually also what the group earlier said, that these tweets which are popular should weigh in more afterwards in the sentiment calculation. So I ran the test with the popular tweets, but you can actually, you can change that. So you might get more that way.
You can just use the most recent.
Yeah.
Okay.
Yeah, that makes sense. Yeah.
All right.
All right. A small slide about distribution of workload. So Jonas is taking care of the streaming API implementation, and also he set up the database that is doing the visualization part, and I am using the REST API. So that's that. And now a short demo of the visualization.
Okay. So where is this?
Firefox, and then drag it to the right, I think. I already loaded it.
So I implement the logic that you can plot the data and visualize. So here's some example, like some slides you like to watch Jon Snow, and you or something like this. This is the overview from season 1 to season 5, and when you click on it, you have the detail from each episode. Yeah. So D3 is a very powerful library that can do a lot of things.
What do you see on the y-axis? It's the number of tweets?
Yeah, there's a number of tweets, yeah.
So is this sample data or is this actual data?
This is dummy data.
Dummy data, yeah.
Dummy data, yeah.
So this is the actual tweets about Jon Snow, not necessarily positive or.
Yeah, it's just about Jon Snow.
What's that?
It's dummy data.
It's a dummy data.
Yeah, I understand it's dummy data, but it's
Is it number of tweets or is it sentiment score?
It's a number of tweets, yeah.
right.
It's just a number of tweets.
Yeah.
Okay. Okay. But that's not what you're aiming for, right?
No, that's just D3 experimentation, I guess.
I mean, it should be pretty easy afterwards to just change the values to input. And then
But yeah, just have to the sentiment analysis. Okay. You're just showing us that you were able to visualize it.
We have something on the screen.
Okay.
That is an achievement for us.
Okay, fair enough. I have a question for both groups actually. So the guys before were covering event handling. You guys were covering FRPs. Did you find that covering the topic and doing the project coincided in some way? Did you use any of the concepts that you learned in the project?
Well, they use callbacks, but there's besides that, there's maybe 3 events recently, but not much.
Did you guys incorporate that FRP?
no.
Not at all.
I mean, maybe if we have time in the future, it could be done also, because it would be handy with the streaming API, because I think that's like a good use case to use it. But since we, at least Jonas and me, were JavaScript beginners, we just had to get used to the whole to language in whole, so it was difficult to dive right into functional programming.